hey, kids.
Hi, Grandpa. Tell us a story, Grandpa.
Yeah, Grandpa.
All right. Have you heard the one about RNA polymerase II?
No, what is that?
Yeah, who's RNA polymerase II?
Well, you see, it all started in a Drosophila cell, as DNA was being transcribed into RNA. It was all a normal day for RNA polymerase II.
I believe it was 23 degrees Celsius, and he was about to go to work. He was feeling sad because he could never do anything on his own, and always needed a lot of help from others to carry out both initiation and elongation of transcription. In order for RNA polymerase II to start his day, he would wait for his co-workers GAGA factor and NERF to uncoil the DNA. NERF is an ATP-dependent nucleosome modeling complex, and GAGA factor serves as the recruiter. When RNA polymerase II saw the GAGA factor coming in the distance, GAGA swiftly bound itself to the GAGA sequence and called in for his sidekick, NERF. NERF was incredibly active and was able to uncoil the DNA from histones so that RNA polymerase II could access the DNA. Suddenly, RNA polymerase II was surprised by his friends TF2A, B, D, E, F, and H, who all lifted him up and carried him towards the DNA. He demanded that they put him down, and he insisted that he could get the work done himself. But before he knew it, he was already at the DNA, and TF2D had bound itself to the promoter. RNA polymerase II was especially jealous of TBP, the TATA binding protein used in all types of polymerases, and required for RNA polymerase II to bind to the DNA near the initiation start sites. Once RNA polymerase II is in the correct orientation and at the right start site, he can head to work, transcribing the DNA for the cell, unlike other RNA polymerases. RNA polymerase II needs helicase subunits and transcription factors, TF2H, to unwind and separate the DNA using ATP hydrolysis.
Aw, come on guys, RNA polymerase 1 and 3 don't need all this energy to do this.
As it began elongation, and free ribonucleotides entered the funnel of RNA polymerase II and formed complementary base pairs through nucleophilic attack. The finished portion of RNA exited through the 5' end of RNA polymerase II, and a loop within helps keep the RNA and DNA separated. Then all of a sudden, two bullies named DSIF and NELF approached him.
Hey, we're some negative elongation factors and we're here to stop you!
Yeah, we're gonna stabilize you on the DNA template. We are initiating promoter proximal pausing.
Yeah, we will stop you from completing enough phosphorylation to be properly functioning elongating complex.
Guys, please, not now. I'm having a really bad day.
Well, it's about to get much worse. Mwah!
No, what happens next? He can't just stop there.
Yeah, when will he finish transcribing his genes?
Well, you see, RNA polymerase II was feeling pretty stuck and useless, until he saw the temperature start to rise to a boiling, lava-hot 37 degrees Celsius.
Now, with the increased temperatures, proteins were unable to properly fold. This caused misfolding and eventual aggregation, which would be detrimental to the cell. Increased temperatures had caused HSF to trimerize, so it could now bind to HSE. Now HSF could recruit the mediator to the promoter. This complex can then interact with a PTEFB kinase that phosphorylates the CTD of the RPB1 subunit of RNA polymerase II and the pausing complex of NELF and DSIF, which in turn converts the paused polymerase II into an elongating complex so that hsp70 genes can be transcribed. He then went on to transcribe the gene for hsp70. The RNA for the gene was then translated into proteins, and those proteins were able to help the proteins properly fold in spite of the extreme heat. The Drosophila cell was finally saved.
So, Grandpa, he saved everyone.
Does that mean he realized the value of friendship and working together as a team?
No, kids. He realized he was useless all by himself. Now go to bed.